Alright, today I'm going to talk about the basic way to troubleshoot a drive-through service window, the loop detector. We have our EDI, the LMA 1250 right here. This is our loop detector. Sits into this mounting bracket right here, it just pushes inside. We're always going to test these top two screws here. This is where the loop ties into. And I'm going to simulate that this is the underground loop that's poured outside in the concrete. So the car will drive over this, and then it'll send a small amount of voltage to the LMA 1250, and what it does is it closes a relay in there, and it's going to short these two screws out right here. So to test the loop, we have our LCR meter. So we're going to put our LCR meter on the 200 ohms, and we want to check to make sure our meter is working. We're going to take our two leads and short them out, and we should go down to almost zero. So here we're at 0.1, 0.2. So we know our leads are good and our meter's working. Alright, with our leads on the mounting block here on the loop side, we're going to come up and we're going to spin our meter up to 200 UH. One more. 200 UH, and we're getting about 79 microhenries right now. Typically in the field when you're testing, you want this number to be about 90 to 150. That would be a good loop. Since we're just testing on a little piece of Cat 5 here for an example, we're somewhere about 80 microhenries. So we know the loop is within spec. So if we're going to bring it down, we want to go to ohms, 200k ohms, and if you were testing at the loop, you want to be somewhere about 0.6 ohms to 1 ohm. So if you're within those testing at the loop, you're in spec. If you're testing at this block here, of course it's going to be a little higher because you're going to have inside wire from here that's going to go across the building and down the conduit to the J box. So you'll have maybe 2, 3, 4 ohms on that. That'd be normal. So right now I have just a regular volt ohm meter hooked up to these two screws here. This is relay A output, and the LMA 1250, when a car drives over the concrete, it should send the information to here, and it's going to close relay A or B, or maybe both. Depends how you have it set up. But when the relay closes, it's going to dead short these two out here. So our meter should register a dead short when somebody goes over that car. So I'm going to put our LMA 1250 in the slot. Once it boots up, that'll give you a 2-digit code, so that means this is operating at a 56 kilohertz loop, which is good. Spec is between 25 and 150 for an LMA 1250. And when you put this in, you want to set this default. We want to try to get a register of 5. It's very important that if you press reset on this, you don't do that with a car over the concrete. So the driveway has to be clear. You could press the reset button, and then you want to push this up so you see a 5, and then it'll come back down to 0. So when a car, I just have a little metal tray here, when a car comes over, you'll see it registers. Output A and B is on, and you get a number. Alright, so that's how that works. And with that on there, you want to try, when a car's over the pad, you want to try to adjust this down to 5 and keep it there. So right there you go. So we'll drive away, and then we come down on top of it. There you go. And there's also a relay B. Alright, so if we flip the LMA 1250 over on the back side, we're going to see dip switches. So if we put dip switch 6 to the up position, we just activated the B relay on here. So potentially you could get 2 relays, A and B. Sometimes you might need to turn the B relay on because cars go over this for several years, and it might get a couple hundred cars a day, and the A relay just might break or not open and close anymore. So we can go down to the B relay just by flicking that switch up. We would have to take our wires off the A relay and put them down to the B side like I did here. The 2 outer screws are the B relay. So let's put this in place here. There you go, output A and B lit up. And we got a dead short on that, that's why the meter's buzzing. So that is a fully operational loop. All right, appreciate your time.